get some extra practice, why don't we just pick some seemingly difficult lines to plot? So how about something like, get my pen. Something like y equals, let's think of an ugly number. What's an ugly number? Maybe like, let's make it, no, let's not do a fraction yet. Let's just make it 2.27x minus 3.14. Actually, that's kind of a pretty number because it's an approximation of pi, but nevertheless, it's a decimal. So how are we going to draw this? Well, first question, what is the y-intercept of this line? Well, when you plug in 0 for x, you always get this number, which in this case is negative 3.14. So that's our y-intercept. So let's go down 1, down 2, down 3. That's about negative 3.14. And what is our slope? Our slope is 2.27x. So every time we go over 1, we go up 2.27. So if we go up 2.27 from this, we're a little under 1 around here. Actually, we're at negative 0.87 exactly. So our line is going to look like this. And it's always good to check ourselves afterward. So we've got a negative y-intercept. So we're starting in negative. Yeah, we've got that drawn. And our slope is positive. So that means we're climbing up the hill. So, okay, that's good. We're climbing up the hill. How about y equals negative 5.14x plus 8.12? Well, again, this is a similar process. So we start out with finding our y-intercept, which is this number, so 8.12. So let's go up 1, 2, 3, 4, 5, 6, 7, 8. So we're just a bit above 8. 8.12. And when we go over 1, how far do we go down? Well, we look at our slope, and we go down 5.14. So that's going to come out to, well, 8 minus 5 is 3, and this is 0.14, so bigger than that. So we're going to be a little bit below 3, right there. Actually, we'll be at 2.98. Right, and then we can draw our line, because we only need 2 points to draw the line. And we'll double check ourselves. Y-intercept is positive. Yeah, it crosses in the positive y zone. And the slope is negative. And yeah, we're going down into a valley or a water slide, however you want to think about it. So that makes sense. Okay, cool. So that's working with decimals. What about fractions? Yeah, let's try some examples with fractions. So first off, how about y equals 5/2 x plus 3, something like that. So one way to go about this, you can always convert a fraction into a decimal. So if you were to divide 5 divided by 2, you can even just punch that into your calculator if you want. That's equivalent to y equals 2.5x plus 3. And we already know how to graph decimals, so that's pretty straightforward. Just find your y-intercept, 1, 2, 3. And every time you go over, go up 2.5. 1, 2.5. yeah, so you can see I started running out of room over here. If you ever run out of room on your graphs and don't really have room to extend it, you can always go backwards. Go left 1 and then go down 2.5. So if we were to do that, we'd go left 1 and down 2.5, we get to 0.5, and yeah, that still works. You get the same line either way. But fractions are also or decimals are also kind of not so elegant to deal with sometimes. So there's a way to use these fractions more nicely, and that's by, instead of going over just 1, you go over 2 in this case, and then we'll go up 5. So now that might seem kind of weird right now, so let's do an example of this. So we're going to start at the same place, 0, 3. And now, instead of just going over 1, we're going to go over 2, because 2 is the bottom number here. And then we will go up 5. So we're going to get all the way to 8. We can draw our line that way. The reason that works is, should go through. Let's try that again. That's a little bit better. I gotta work on drawing my lines a bit. Still new to this. Okay. So the reason why this works is that when you multiply 2.5 by 2, you get to 5. So if you take 2 steps over and then you just go up 2.5, up 2.5, as long as we multiply by the bottom number, like put in x is 2 here, then when we multiply the fraction, then it comes out to 5. So that's our increase there. Just to convince you of this though, so if we do the normal way where you go 2.5, you go over 1, up 2.5, so starting at 3 up 2.5, we get to 5.5, which is right here. And then if we do that again, over 1 and up 2.5, well, this is up 0.5, then up 1 more, then up 1 more, then we're right at 8. So that also works out. Either way works, really. We'll just do one more example of a fraction problem before we call it quits with these. Why don't we do something like y equals, let's make a messy fraction. Let's make it like 8/5 x plus 10/12. So if we want to draw this, we're going to start out at 10/12. And 10/12, the fraction, is just a little bit under 1, right? Because 1 is 12/12, and 10/12 is almost 10/12, but not quite. So let's just put a dot that's just a little bit under 1. Now, it'd be kind of annoying to actually convert this to a decimal and then like convert that to a decimal and then add it every time. But when we use the trick over 5 up 8, that makes our life a lot easier, because now we can just go over 5, 1, 2, 3, 4, 5, and we can go up 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 right there. And if we go up 8 from here, well, we're a little bit under 1. So let's go a little bit under 8. or oh, sorry, no, that should be going 9, not 8. Yeah, because 1 plus 8 is 9. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll go a little bit under 9 and over 5. Right about here. So now we can just draw the line like this. That's a lot easier than converting to decimals. We've got a few minutes. Why not just do one more just to solidify the concept? But let's do a negative. Y equals negative 2/3 x plus 1/4. So let's draw this. So 1/4, that's our y-intercept. So let's just say 1 is here. That's going to be about right here, about 1/4 of the way up. And our slope is negative 2/3. Now, again, we could convert to negative 0.666 and then just minus it and see where we end up. Or we can do the easier way, just go over 3 and down 2. 1, 2, 3. 1, 2. So let's go down 2. So here is after going down 1, after going down 2, and then over 1, 2, 3. Now this is what our line looks like. This is supposed to go through that. Let's try that again. There we go. That's better. Yep, and negative slope, so we're going down the slide instead of climbing up the mountain. Makes sense.